Hi, I am your instructor Sherry Lose, and I'm going to lead you through the first of my learning videos here in Canvas for OLI. We're going to pick up on Module 7. In this mod guide, you are working on some materials on your own with OLI, some definitions of different kind of variables that we're going to use, some information coming from a stacked data table. We're actually going to take a look at this data table a little bit later in StatCrunch and do some data analysis of our own. And that's where you were to have stopped before this video. So let's start here. Number 3 goes along with a did I get this activity in OLI on page 30. So we're told that in this study, researchers investigated the lifespan of animals living in captivity. So investigated lifespan. So that's telling us that lifespan is our variable of interest. And that is, of course, going to be, let's just go back, it's going to be a quantitative, or what can also be called a numeric variable. They gathered data on 30 different species of animals. So we've got 30 pieces of data. And then they're giving us some information here. Lifespan is the age of the species in years. Researchers want to summarize the distribution of lifespan. So when we're looking at a distribution, we're trying to get some information about the range and the characteristics of that variable. So really the first way we do that is with making a picture of some kind. The picture or graph A is what's called a histogram. We've got bars. The height of each bar is indicating some quality experienced by that individual, or some numeric value of that variable. In graph B, we have a dot plot. So in a dot plot, our variable is here on the horizontal axis. The axis is scaled to give us the possible outcomes of that variable, and then we're just placing a dot wherever we find that data. And so that's why graph B is going to give us a much better display of our variable lifespan. In graph A, lifespan is on our vertical axis. So if I'm trying to get some sense of how lifespan is laid out, I'm trying to look across to see how many individuals have a bar this high, how many individuals have a bar this high, and so on and so forth. So it's just a little more difficult to get from that left-hand picture. So for summarizing, the distribution of lifespan, graph B does a much better job. Next question, which are accurate statements? So we're going to describe these statements as either valid or invalid about the distribution of lifespans for this group. A typical lifespan for species in this group is 12 or 15 years. Well, what we really need to zero in on is this word typical. And here at the beginning of the course, it's just coming in a fairly generic way. Typical, we're going to think of as maybe some kind of a central value for that variable. So where would a central value for lifespan be? Well, we can see that the entire data set varies from either 0 or 1. It's hard to tell where that first block is. And then it goes up to 40. So just cutting that in half, we would be at 20. But we can see there's much more data to the left of that halfway mark than there is to the right. So a central value is going to be somewhere over here then to the left of center, where that larger proportion of data is found. So that makes this statement valid. Where is a lot of this data? Well, this tall bar is around 12, this tall bar is around 15. So that's how we get to this statement, that a typical lifespan is 12 or 15 years. All right, the next one, lifespans ranged from a year to 30 years. Well, no, we can see that there is this one piece of data past the 30-year mark, so that makes this statement invalid. Over half of the species lived from 12 to 20 years, or exactly 20 years. Okay, well, let's take a look at all the data we have in that interval. 6 here, 5 there, 1 piece of data, 5 pieces of data. So we've got a total of 10 and 7 more, so 17 pieces of data in this interval. We had 30 pieces of data total, so yes, that is over half. This is a valid statement. Last one, it is unusual for an animal species in this group to live longer than 25 years. Okay, so typical is where we get some sort of central value. Unusual means that it doesn't happen very often. And certainly, if we look at 25 years, it does not happen very often that an animal species lives longer. So that is a valid statement as well. In our next video, we're going to take a look in our data analysis program StatCrunch. So be sure that you have access and are logged in to get started in our next work. See you there.